In this video, I'll be covering 3 important things related to circles. Number 1, properties of angles in a circle. Number 2, cyclic quadrilaterals. And number 3, tangents to circles. Remember to watch until the end of the video if you want to know how to solve KBAT Hons questions related to circles, and we'll start right now. Hello everyone, my name is Shirley and welcome back to my channel. If this is your first time here and you would like to improve in your math skills, start now by subscribing and clicking the bell so that you don't miss anything. Let's take a look at the properties of angles in a circle. Firstly, we need to understand what's the meaning of angle at the circumference and central angle subtended by an arc. Let's look at these diagrams. So I label this as diagram 1, diagram 2, diagram 3, okay, diagram 4 and diagram 5. Okay, let's look at the first one. So this angle is subtended at the circumference, okay, and this one we call it inscribed angles. So these two are inscribed angles because it lies on the circumference of the circle. Okay, whereas what's the meaning of central angle? So central angle means the angle lies at the center of the circle. Okay, for example in diagram 3, okay, so theta is central angle. Okay, let's look at the properties of the circle by looking at diagram number 1. Okay, the angle subtended by the same length of arc. For example, I label this as length of arc PQ. Okay, so therefore the angle here will be the same, means theta 1 is equals to theta 2. It means that if this is 20 degrees, here will be 20 degrees as well. Okay, I call it butterfly method because it looks like a pair of wings, a pair of butterfly wings. Okay, so remember this. Okay, next is, okay, let's look at number 2, diagram number 2. So these two arcs are the same. Okay, so let's say this is PQ and this is RS. So if the length of arc are the same, the angle subtended at the circumference will be the same as well. So this is theta 1, this is theta 2, so therefore theta 1 is equals to theta 2. Okay, let's say if this is 10 degrees, here will be 10 degrees as well. Okay, let's look at number 3. Okay, central angle. If the central angle is subtended by the same length of arc, let's say this is AB, arc AB is equals to arc CD. Okay, so therefore the central angles theta 1 and theta 2 will be the same. Okay, let's say if this is 25 degrees, here will be 25 degrees as well. Okay, let's look at diagram number 4. So the angle subtended at the center is 2 times the angle subtended at the circumference. Okay, so subtended by the arc PQ. Okay, so here will be 2 times at the center. The central angle will be 2 times of the angle at the circumference. Okay, for example, if this is 30 degrees, okay, the central angle will be 2 times 30, which is 60 degrees. Okay, let's look at number 5. So if the angle is subtended by the diameter, okay, so this is diameter. Okay, so here will be 90 degrees. Okay, and remember this one is a right angle triangle. Okay, and if the hypotenuse of the triangle is also the diameter, therefore the angle is 90 degrees. Okay, here is also 90 degrees. Okay. This is one of my favorite part of the chapter because a lot of questions that comes out in exam are related to cyclic quadrilaterals. So there's one thing you need to know about cyclic quadrilaterals is you have to make sure that the 4 vertices lie on the circumference. Okay, so the 4 vertices lie on the circumference. Okay, this is the first thing you need to make sure. Okay, and the sum of the opposite interior angles is equals to 180. So for this case, A plus B is equals to 180. Okay, and C plus D is also equals to 180. Okay, let's look at the second diagram. Okay, let's say this is chord PQ. Okay, chord PQ, okay, is extended until R. Okay, so therefore this angle, use angle E, is equals to angle A. What is the meaning of tangent? Tangent is a straight line that touches the circle at only one point. Okay, let's look at these diagrams. Okay, I labeled this one diagram number 1, diagram number 2, and diagram number 3. So all these 3 diagrams have tangents. Okay, in diagram number 1, ABC is the tangent. So this line is the tangent. Okay? So ABC, and then this tangent intersect with the radius, this is radius, okay, at point B, okay, at this point. And point B, we call it point of tangency. Point of tangency. If the tangent and the radius intersect at point of tangency, a 90 degrees will be formed. Okay? Okay, let's look at diagram number 2. So there are 2 tangents here, AB and BC. Okay? So, and it's intersect at point of tangency A to form a 90 degrees here. Okay? And then the tangent BC intersect with the radius at C, point of tangency C. Okay? So if the 2 tangents with center O and the points of tangency A and C, okay, meets at point B, okay, so therefore this angle, which is theta 1, is equals to theta 2. Okay, it means that if this is 20 degrees, here will be 20 degrees as well. Okay, and same as the alpha, okay, alpha 1 will be equals to alpha 2. Okay, so here for this case, if this is 20, this is 90, so 90 plus 20 is 110. Okay, so therefore to find alpha, it will be 180 minus 110, then we will get 70 degrees. So if alpha 2 is equals to 70 degrees, therefore alpha 1 is also 70 degrees. Okay? Let's look at diagram number 3. So if there is a triangle, okay, whereby the 3 vertices lie on the circumference, and there is a tangent AB, okay, which touches the circle at one point. Okay, so therefore the angle A here, okay, is equals to D. Okay, and angle B is equals to angle C. Let's look at question number 1. Wow, this one looks a bit challenging, don't you think so? Okay, let's solve this. The diagram below shows 2 circles. PTQ is a common tangent to both circles. Given the length of KT is equals to LT. Okay, KT equals to LT here, okay? And then angle KLT is 61 degrees here, okay? And angle SNT is equals to 42 degrees, which is here. Okay, calculate the angle LTQ, which is here. Okay? So because the length of KT equals to the length of LT, so therefore this is 61 degrees. Okay? And then according to the properties of circles, the angle LTQ is also 61 degrees. Okay? So here, I'm going to write here, okay, angle LTQ is equals to angle LKT. Okay? And therefore is equals to 61 degrees. Okay? This is very simple. It's not that challenging though. Okay, let's try B. Yeah, the value of X. Okay, this one a bit challenging. Okay, so I need to find what is this angle first. Okay, so I'm going to use a calculator. I'm going to calculate. So 180, which is the sum of angles in a triangle, minus 61, so I will get 58 degrees. So here will be 58 degrees. Okay, and the opposite angles here is also 58 degrees. So I'm going to write here 58 degrees. Okay, and then you see this is 42. So therefore this is also 42. Remember the butterfly method? Okay, so to find X, okay, to find X, I'm going to use 180. Okay, X equals to 180 minus 58 degrees. Okay, minus 42 degrees. Okay, let's calculate this. 180 minus 58 minus 42. So we get 80 degrees. Okay, so therefore X is equals to 80 degrees. So I'm going to write here 80 degrees. For question number 2, the diagram shows two circles centered at O and P respectively. ABCD is a common tangent to both circles. Calculate the area of trapezium OBCP in cm square, correct to three significant figures. So let's look at this. So if you see a trapezium, you divide it into two parts, okay, which is a right angle triangle here. I label this as point Q, okay, and also a rectangle at the bottom, okay. So for this, I'm going to find what is my length of OQ first, yeah. So OQ, I'm going to use 5.2 minus 4.5 because PC is 4.5, therefore QB is also 4.5. So 5.2 minus 4.5 will get 0.7. So here is 0.7. Okay, next I'm going to find what is this angle. So since this is a rectangle, here must be 90 degrees. So 93 minus 90 is 3 degrees. Okay, so to find the length of QP, which is here, this is equals to BC. Okay, so for this, I'm going to use tangent. So tangent 3 degrees is equals to 0.7 over BC. Okay, so to find BC, so BC is equals to 0.7 divided by tangent 3 degrees. Okay, so let's calculate this. 0.7 divided by tangent 3 is equals to 13.357. Okay, so 13.357 cm. Okay, so now we can calculate the area of the trapezium. Okay, so I'm going to label here 13.357 cm. Okay, so I have all the sides already. You can calculate the area of trapezium OBCP. Okay, and the formula is half times the two parallel lines added up together, okay, which is OB plus PC times with the height of the trapezium, which is BC. Okay, so equals to half times, so OB is 5.2 and PC is 4.5 times with BC that we have gotten just now here, so 13.357. Okay, so let's calculate this. 4.2 plus 4.5 first, after that divided by 2, and then times 13.357. So we get 64.78145, but we have to correct to three significant figures. So it will be 64.8. Okay, so 64.8 cm squared. So that's the answer. Let's look at question number 3. The diagram shows a circle with center O. Given the radius of the circle is 3 cm, which means that here is 3 cm. Okay, QR is 8 cm here, and PQR is a tangent to the circle. Determine angle TRQ, which is here. Okay, so OQ is the radius. So this is the radius, and it intersects the tangent at point of tangent CQ to form a 90 degrees. Okay, so for this, I can use tangent to find the angle TRQ. Okay, so tangent angle TRQ, okay, is equals to, so 3 plus 3 is 6 over 8. Okay, so to find the angle of TRQ, I'm going to use tangent, shift tangent, okay, of 6 over 8. Okay, so let's calculate this. So shift tangent of 6 over 8, so we'll get 36 degree and 52 minutes. Okay, so we get 36 degrees and 52 minutes. Okay, so that's the answer for A. Okay, now let's solve for B. Okay, the length of ST is over here. Okay, and then because SOQ is a diameter, so therefore the angle subtended here is 90 degrees. Here. Okay, so here we've already gotten 36 degrees and 52 minutes. Okay, so we need to find what is the length of QT first. Okay, so to find the length of QT, I'm going to use sine. Okay, so sine for B, so sine 36 degrees 52 minutes, okay, is equals to QT over 8. Okay, so to find QT, I'm going to use 8 times with sine 36 degrees and 52 minutes. Okay, so let's calculate this. So sine 36 degrees and 52 minutes, then times with 8, then we will get 4.8. So QT is 4.8 cm. Okay, so this is 4.8 cm. So to find ST, I'm going to use Pythagoras theorem. Okay, so ST is equals to 6 square, okay, 6 square minus 4.8 square, and then I square root the answer. So it's equals to, okay, let's calculate this. 6 square minus 4.8 square, and then we square root the answer, we'll get 3.6 cm. Okay, so 3.6 cm. So that is the answer. Let's look at question number 4. The diagram on the right shows a circle with center O. PQ is a tangent to the circle. So if this is a tangent, so therefore this is 90 degrees. Okay, so A, find the radius of the circle. So let's say this is R and this is also R. So I'm going to use Pythagoras theorem to find my value of R. Okay, so for A, so 8 plus R, which is the hypotenuse, okay, whole thing square, is equals to 12 square, okay, plus with R square. Okay, let's expand this. So 8 square is 64, plus 2 times R times 8 is 16R, plus R square, okay, is equals to 12 square is 144, then plus with R square. Okay, so let's solve this. So 64 plus 16R, okay, is equals to 144. Because R square, when we shift to the right, okay, we minus R square, it becomes 0. Okay, so to find 16R, so I'm going to use 144 minus 64, I will get 80. Okay, so to find R, I'm going to use 80 divided by 16, so I will get 5. So therefore R is 5. Okay, so 5 cm. So therefore he is 5, he is also 5. Okay, so next, let's solve for B. Okay, so length of OP. So length of OP is very simple. Okay, so OP is equals to 8 plus R. So just now we have found that R is equals to 5. So 8 plus 5 is equals to 13 cm. Okay, so now let's solve for next one. So for C, okay, so for C, find the area of triangle OPQ. So area of triangle OPQ is equals to half times base times height. Okay, because it's a right angle triangle. So half times, so the base is 12 times with the height, which is 5. So equals to, so half times 12 is 6. 6 times 5 is 30. Okay, so 30 and the unit is cm squared. Okay, so that's the answer. To master this chapter, you need to do lots and lots of past year questions. So stay tuned to my next video, which is PT3 past year questions related to circles, coming up soon. Bye!